There we go. Yes, welcome everyone. My name is Mark Garneau, and I'll be joined today by Amanda Russet. This is our second session in this series, although in some ways it's part one because it's the first time looking at a very specific category of routines. The first session was sort of general about routines and so on. We will be making recordings available, slides available. Once we have all that set up, we'll be sure to communicate with you. I'd like to, oh, by the way, at any time, feel free to type any questions or comments in the chat. Amanda and I will be monitoring that, and we'll reply either live or through the chat as the case may be. And if there's time at the end, I doubt there will be, but if there's time, we can also have some open Q&A and where you can unmute yourselves and ask your question that way as well. Okay, so just first, I'd like to acknowledge that, to take this opportunity to acknowledge the shared traditional territory of the Coast Salish people on which Surrey schools are located, because that's where I work. But also all territories of the people here today, where you live and where you work, and recognize all of the First Nations who have signed the Aboriginal Education Enhancement Agreement. All right, we're going to get right started in with a routine. This one, we're not going to spend a whole lot of time on it, but it is a nice routine that gets at this idea of looking for similarities and differences. And I first learned about this routine from Kathy Marks Kirpan, who is a educator and author from Ontario. And the way this routine works is you are presented with three things. I guess it doesn't have to be three, but oftentimes she does it with three things. And there are going to be some clues provided. And the task is about figuring out which of these items, in this case, numbers, match each clue. Now, because we have a K-12 audience, this particular example is more elementary focused, but I'll show a secondary, upper secondary example in a little bit. But these clues are going to progress from primary up through intermediate. So you wouldn't certainly give all of these clues to whichever grade you're teaching, but you can make decisions about what clues you would like to use. Okay, so you can just do this mentally for yourselves right now. Which of these is odd? Which of these is greater than 10? Which of these is a number of eggs that can fit in a carton? Notice that we could bring in context as a meaningful use of number. Which of these is easy to double? What I like about that clue is that it's not about a right or wrong answer. It's up to, for each individual to be able to think about, can I double this, or do I know how to double that? Is a multiple of 5? Is a square number? Is a factor of 36? And finally, is more than 25% of 40. So just pause here for a moment, because you can think about whatever grade you're teaching and what sort of clues you might use for these numbers, trying to distinguish clues that where it might apply to maybe only two of the numbers and so on. But notice that what we're trying to do through this is, here we have three numbers, just three numbers, almost chosen at random. But these are some things that make these numbers either equivalent to each other or different from each other. And so a lot of number sense is not just seeing a number as a quantity, but also seeing how does that number relate to and connect to other numbers. Now, this routine isn't just about the initial clues. I like to follow it up with giving students the opportunity to write their own. So I might leave that open and say, okay, write whatever clues you want that you can come up with and share them with a partner. Other times I might be a little bit more specific and say something like, write a clue that matches all three numbers, or write a clue that matches none of the numbers. Of course, that particular one I thought was a clever prompt at first, but when you really think about it, that's probably the easiest one to answer, because it's pretty easy to come up with clues that matches none of them. You could even say, well, none of them are chocolate or flowers. Matches only one of the numbers, and which number did you pick? And so these are the kind of prompts where they can then go through and do a whole bunch of different clues for, which also can be a nice opportunity for some assessment as well, to know where they're at with their knowledge and understanding of these numbers. But not just limited to numbers, we can do this activity with things like shapes. I'll just go quickly through these ones. Again, starting at primary and going up a little bit into the intermediate grades. Has a pointy end, has a rectangular face, can slide, can roll, can stack, is a prism, has parallel faces, can be used to package something. Notice just with, if we look at the one where is a prism and has parallel faces, whenever you have the same objects satisfying the same clues, you can have a conversation. It's like, is there something about these clues that is that the reason why that applies to both of them? And certainly in this case, it's what defines a prism, that it has parallel faces, and that's a worthwhile thing to discuss coming out of that. And once again, even with shapes like this, you could prompt for write your own clues that satisfy all of them, one of them, and so on. Here's a secondary example, grade 11 specifically, pre-calc 11, foundations probably as well. I've put a red dot at the origin just because the screenshots are not the clearest to see where the origin is. But I'll go through these fairly quickly just because I'm trying to give an idea here. Leading coefficient is positive. The constant term is positive. The vertex is -1, 4. Has 2 x-intercepts. The linear term is positive. So you'll see here there's a lot of use of vocabulary as well as concepts and seeing how those concepts play out. But it's not, rather than just focusing in on one parabola and graph that and what are its attributes, looking at how these attributes connect across a whole family or range of parabolic functions. By the way, that last clue, that the linear term is positive, is a bit of a tricky one. You might want to think about that if you're teaching that course or dealing with quadratic functions. Yes, once again, we will be sharing the slides at some point, hopefully soon. So if you don't have to worry about taking a screenshot or writing these clues down, you will be able to access them. Although if you're eager to do it tonight, then maybe you'll want to take a screenshot, but this will be disappearing in 3, 2, and 1. So some things to take out of a routine like this. It reveals similarities and differences between mathematical objects. And those mathematical objects can be numbers, shapes, graphs, patterns, ratios, displays of data. There's no limit on what those can be about. There's reasoning, justifying, vocabulary, conceptual understanding, creative thinking when it gets to where they get to create their own clues. And as I just said, can be used with any mathematical content. So looking back at what a routine like this can do and tying into what we did in the first session, and that will be lingering through all of the different routines that we explore. So something to be mindful of is that routines can be instructional. So there is both mathematical content and curricular competencies that emerge through these tasks. They're great for building community because every student can have a voice and place in sharing their thinking or sharing their ideas about what we're looking at. They're engaging, both mathematically and also because students feel that they belong to a community, they're going to be more likely to be engaged. They're quite practical. They don't take very long usually, and there's so many out there that are available. And as well, they're very valuable for doing observational assessment, because a lot of these routines are done orally in a either in small groups or whole class. And so there's a lot you can observe based upon what students say, either to the class or to a partner. Oh, I see a question popped up. Yes, great, thank you. Now, normally, I think the next slide is going to go to Amanda. Yes, it is. But just before we do that, in the future sessions at this time after an opening activity, we're going to have some open sharing. And we thought, and that sharing will be based upon a takeaway. So at the end of this session, we'll be giving you a takeaway, something to try. And then we hope that a few people will be willing to share about their experiences later on that. So I'll say more about that later, but today, because the first session was really just introductory, we're not going to have that sharing time. But on to our next routine, and I'm going to pass it over to Amanda.
So our next routine is called Which One Doesn't Belong? And so we have some objects in those squares. And what I'd like you to do is just take a moment and think about which one of those doesn't belong. Is it the basketball or the brownie or the donut or the cake? And I'm going to give you a couple seconds to think about that. And then when I count down, we're going to put our answer into the chat and we'll kind of see where we're at. If you feel like you've got one of these nailed and you'd like to push yourself a little further, maybe you could think of another reason why one of those other boxes might not belong. And if you have some more time, maybe you could figure out a reason for another object, or maybe even another one. Okay, here we go. 3, 2, 1. So much more fun in a classroom where you can actually ask some students and it just seems a little bit better. But the nice thing we got here is, so someone has said that the basketball because you can't eat it. Someone has said the brownie because it's the only one that is not a circle or it is a square. We could say that maybe it's the donut because it's pink. And then we also have someone said cake, I think, because cake is a cylinder. So lots of variety there of what we might be able to find from those ones. Click mark. So why would we use which one doesn't belong? So the focus here is not actually on the response. And so if we're in a classroom, we want to be really focusing on the student's ability to communicate their reasoning and then also their justifications. So if we do say basketball, we want the students then to respond with a reason for why they decide that that one doesn't belong. This activity also offers entry points for all students. They are cleverly designed so that there isn't a wrong answer. We can find a reason why each one of those doesn't belong. It promotes mathematical discourse and it connects mathematical concepts. So if we move towards some other things, we can really pull at those mathematical concepts. So a great place to grab some of these is actually at wodb.ca. It's really nice. You can go there and grab them. What you might want to do is actually just take a copy of the image. So that's what we did today. We copied that image and then threw it into a slide deck so that it's clear on which one we're working on. Mark. So they are organized on that page in a variety of ways. So these ones are showing shape. So I've got a variety of levels here so you could see what that looks like in terms of some shape type things.
Are you going to give them time to pick one and do it, or what would you like to do there, Amanda?
I kind of like the next one better, Mark. The number ones.
Okay, we're
Let's do
going
the
on.
number ones.
We're going on to number.
So these are our number ones. So we've got some of our earlier grades up to some more advanced grades. And I am going to take a moment at this time. We'll just look at which one do you think might not belong, or do you have some reasons, or can you find the reasons that each one of those doesn't belong? So I do want to talk about the center photo there, the one with the colors of green and blue and orange and yellow. And I did this one in a class the other day. And the teacher came up to me afterwards and said that she was so excited because one of her students actually contributed to a math conversation. And the math conversation, or what that student was able to contribute, was actually that the 2 and the 8 one didn't match the green square. And the reason was because it had the circles. And so that child is not at the place yet where they are talking about multiplication, but at least had a moment where they could actually enter the conversation and feel like they contributed to the classroom because they could see that that one had 2 circles. And so that student in that moment had a moment of math success. And you could actually see that student really light up in the moment. Okay, next one, Mark. So we could do this with graphs. So there's a variety of things that we could do. The site is awesome because it does have it into buckets for you. So if you're working on addition or subtraction, you can go there and find some things. And so we can have some really intentional conversations around the content that we are teaching. Take it away, Mark.
Okay, we're whizzing through this. We'll have lots of time at the end, I think, to open up and have some questions or share some ideas. I'm just going to keep this here a little bit longer in case other people are thinking about this. Where we're going to go next is a little bit more of an advanced version of which one doesn't belong, as well as how you may create your own. So maybe even just looking at these ones here, to notice some things about them, that there is, when something doesn't belong, it's because there is a distinguishing feature about it. And all 3 of the other ones don't have that feature. So that is something important. So bringing this back to the idea of similarities and differences, we're finding the one, like which one doesn't belong, is about the difference. But it's also good to be mindful of the other 3 which have a similarity. And that's what contributes to the difference of that one that does not belong. And so when Amanda talked about the concepts and connecting concepts that comes to this routine, we're looking at attributes of whether it's shapes, numbers, graphs, whatever we are looking at, we're looking at some attribute of that concept and looking at what makes these 3 the same and what makes that other one different. And then how can we have it so that for each one of them, there is that single difference and yet something common to the other 3. So that's where we're going to be building up to. But first, a little bit more of a challenge. And we'll be taking some time to do this one. It's about incomplete sets. And these are also, there's a few of them available on the website. I took one of those and then I made a couple of them myself. What's going to happen, I'm going to show 3 different ones, again, different levels. So pick one There will be a question mark as to what the fourth one could be. And I want you to be very thoughtful and mindful about what that missing item could be. So I'll show them now so you can start thinking, but don't share anything in the chat yet. So here they are. So pick one. What could the question mark be? And be mindful that whatever you put there, not only does it not need to belong, but it also can't remove a reason for why one of the others does not belong. So in the first one, for example, if you want to have in mind that the reason why 17 does not belong is because it's a prime number, well, then maybe you don't want a prime number in for the question mark, because then that removes that reason for 17, unless you could think of another reason for 17. So I'm going to give you some time to think about it. When you think you have one of them, then describe it and give some kind of reason why you think that would be a good choice for the missing set. And it's open now. You're welcome to contribute to the chat.
Hey, Mark, I was wondering if I could just respond verbally because we're sharing a computer here.
Oh, absolutely.
I really like the first one for many reasons. And I also think it's really important for elementary teachers to make sure that there's so many more opportunities for success with younger kids. So for instance, we were just, troubleshooting that first square that's got the 17 in it. And besides that question mark not being prime, we would also maybe not make it odd, and we would maybe not also make it the two digits add up to 8 or something like that. So we would make it so there are many ways that students could maybe have success when they're sharing.
Yes, yes. So what I like with that, you picked up on a few things, and we're not expecting kids to pick up on all those features, but that there's a lot of entry, there's a lot of places to enter into where there's a lot of defendable reasons for whatever you choose. And so, yeah, these are more challenging than when you do present for, but we still want to make sure that it's something that they do have that entryway into being able to bring their thinking and share an idea. And there isn't just one right answer. There are tons of possibilities here, and all that matters is that you can defend it. So yes, you did notice in that one that they all add up to 8. So the digits add up to 8. So that could be the distinguishing feature, or some other combination of things like you had said. Some other things here, I'm just reading through. Okay, yeah, I can see where you pick you choose a number by its size, pick a square number or something like that, a kind of number that isn't otherwise represented. It's nice that that one's also single digit. Yeah, how the digits compare to each other is a good possibility. The first one I saw was about the parabola and the idea that it could be something that opens down. All those other three open up, so it could be something that opens down. And also below the x-axis. Well, it could be, because the first parabola in the top left is has a vertex below the x-axis. Maybe you want to make that its distinguishing feature, so you might decide to make the one open down and also be above the x-axis, like its vertex is. The ratio one is interesting. And I'm not going to be able to look at all these clues, but I'm glad. Thank you for continuing to keep doing them, and please keep sending them in. Notice that the first two ratios have the same relationship. They are equivalent ratios. And so maybe in that question mark, we'd want to preserve that ratio, that comparison. But I do like the idea of suggesting that instead of going small part to large part, to go large part to small part. But maybe we would keep that same 5 to 1 or 1 to 5 kind of relationship between the two numbers. Yeah, I see the idea of using repetition on all those ones that are shown. No digits repeat, so you could have repeating digits being something that qualifies. So notice how this really forces us to really think about, okay, in the area of whether it be numbers or ratios or graphs, what are the kinds of attributes that we can think of where we can find those similarities and differences? And then how does that translate into defending our choice? All right, so I'm going to leave this for now, or leave this now because we're not going to come back to it. I'd like to get into creating your own. And through the lens of these, when we're designing these as an instructional routine, not just something to do that's fun, but as to be instructional, because there are a ton of them out there. Teachers, every day I see a new one. Teachers throw something out there, or so on. And a lot of them that I see are just taking any 4 random things that have some connection, but they aren't necessarily thoughtful about looking for those similarities and differences. And there's nothing wrong with that. It's still a good activity. It still gives a nice entryway for all kids to be able to contribute something. But these, if we are a little bit more thoughtful about how we create them, then our instructional goals of doing this activity can become more realized. So first, with a couple of non-examples, we are approaching Easter, so I thought of something that ties into the Easter season, in at least in the way our society, the societal customs and so on, is with Easter items that we see in our grocery stores and so on. So I might make a which one doesn't belong, where I assemble those things together. Now this, yeah, you can certainly use something like this, but notice that there are just so many differences. It's mostly about difference and not enough about similarity. These things are all related in being things that might be part of this season, but there's just so many differences, and so that it's almost like there's too much to do to really make it as instructionally valuable. So how can I improve this? Well, one way would be to make them all about eggs. So now we could start looking for some distinguishing features here. But even still, there's these are very different eggs. They all have circles, so I can't use that. There's wavy lines, zigzag lines. There's a whole mixture of colors. So it's not that this is a bad one. I just think we can do better. So here's how we can approach creating your own. What I find really helps, and I thank my colleague Chris Hunter for this idea of organizing it, is to use a table. So first of all, think about 4 different attributes. So I'm going to be looking at Easter eggs. Think about 4 different attributes that can vary. So I might think of the color of the egg, the kind of design it has, and when there's a design on the egg, what color is that design, and how many of that design are on the egg. And these aren't the only 4. We could look at size. We could look at orientation. Maybe one of the eggs it's on its side instead of being vertical. We could use whether it's got a lot of the same design or a bunch of different designs. That could be another qualification. So this is just an example where I picked 4 things, but we need 4 in order to be able to create this, the usual which one doesn't belong with 4 things. By the way, it doesn't have to have 4 things. We'll be looking at, Math Match was about 3 things. And in a moment, Amanda's going to show you another activity, which is about comparing 2 things at a time. All right, so what about color? So I want color to be the difference for one of the eggs. So I'm going to make one of them blue and all the rest the same color. For design pattern, I'm going to make the second one have that be its distinguishing difference. And the similarity with the other ones is that they will have zigzags, whereas the different one will have spots. For the design color, I'm going to make yellow the difference and pink the similarity. And finally, for the number of the design, I'm going to have 4 of each for the similarity, and I'll make the distinguishing one have 3. So without even drawing it yet, just having a plan like this, it guarantees that there will be similarities between 3 items and a difference with 1 for each of the 4 things that we do. So here's what I came up with. So I'll give you a minute or so just to look at the table, look at the drawing, and just see that they are connected, and that's how it was designed. Even though I have this design or this plan that went into informing it, it doesn't mean that those are the only things that might emerge. Notice at the bottom right that its zigzags are not only a different number, but they're also a little bit thicker. The one in the top right has designs that are of different sizes compared to the other eggs, which all have the same size of design. I know that there are different circumferences, but in terms of their thickness and so on, they're all the same, yet the circles are different. So there are some other things that can still emerge here. And I'm not looking for, as Amanda said at the beginning, it's not about getting the right answer on any one of them. It's not even about getting the right answer about all 4. It's coming up with a reason, justifying a decision, and being able to defend it. And all kids are able to do that with these. Okay, so as you create some of your own or have your kids create them, you might, this whole idea of helping kids to be able to create a which one doesn't belong in this way is a very helpful and valuable thing. It'd be a nice thing to do at the end of a unit, let's say, where that you want them to capture everything that they've learned about a concept. Think about 4 different kinds of things that you learned about this concept and build a which one doesn't belong from it based upon this idea of using a table. Okay, on to our final routine and back to Amanda.
So this routine is called same or different. And so we're going to just take a couple minutes here to look at the 2 images and think about what is something that you see that is the same and something maybe that you see that is different. When I'm doing this in a classroom, I try, especially with our younger students, to just focus on one of those things at a time. So maybe just start with, what do we see that is the same? and then talk about those things as a class, and then come back and talk about what is different. I find that especially with our younger students, going back and forth between sames and differences can be quite tricky for them. So we're going to take a couple moments, take a look at these images here. They are stolen from Math Before Bed by John Orr. And so a couple minutes, if we want to just write a couple of those things in our chat. What do you see there? So I did pick this one for a reason. It has so many things that we can talk about, especially with our audience today. Mark, next slide. But the nice thing about the same and difference routine is it really is pushing kids to look at those similarities and differences and really just focus on those things one at a time and maybe not get so distracted with 4 things going on. It has an entry point for most of our students. Again, it is promoting that mathematical discourse and really connecting our concepts. We have 2 examples of where we can find some of these things. If you want to grab some things that are ready made for your classes, definitely check out both of them. Both of them are really nicely organized, so we can try and find some things that are really tightly connected with our curriculum. So, Mark, next one. These are a couple of the examples of some different things that we might see in our same and different. So just take a moment and think about, or grab one that you feel is resonating with you in this moment, and think about what are those things that you're seeing there that are the same? And also between those 2 images, what do you see that is different? So as you come across these, if you want to throw those in the chat for us so we can kind of share our learning with other people here. So I do want to pull at something that I saw that Julie said, and Julie mentioned that with the 10 frame, so the one in the bottom left corner, that we have 6 circles. And that's something that's the same between both 10 frames. But also Julie has mentioned that there is 4 blanks. And so that's really great too, because now we have this moment where we can talk about that relationship of the 6 and the 4 and how 6 and 4 is actually coming together to make 10 in both of those spaces. And so sometimes when a student says something about the blanks, and it might take a moment and throw you a little bit, but it's actually a moment where we can have a really great conversation with students about those things. So for, next slide, Mark. For next day, we do want to set you up to have some things to take away. But before we really talk about all of our next steps, does anybody have any questions or some things they'd like to share about any of the routines that we've covered, or a comment, or maybe you have tried some of these things in your classroom?
Just one thing I wanted to mention just before we do take those questions is how to do these. They can be projected and have, you know, that small group or whole class discussion. You could print something out and maybe, or print one copy in a classroom and just have it up on the board, and students can maybe write their ideas on Post-it notes and put them up next to the item. It could be done virtually as well through some sort of shared document, or like a Padlet or a Google Doc or something where students can contribute their ideas that way. So there's many different ways that these kinds of routines can be used. And it's a nice routine for, you know, when we've been having to struggle, you know, how do we bring those rich learning experiences that kids have when face to face in a classroom, and yet maybe now they're in a remote situation. You know, how do we bring those same kinds of rich experiences? Well, routines like this do really lend themselves nicely to different environments. Anyway, so open floor with any questions or comments before we get to the next steps as we wrap up.
I think maybe one other piece of advice might be that we don't need to routine fatigue kids. So if we did a which one doesn't belong, we might not want to do 4 or 5 of them in a row, especially not in one space. So I have seen in the past where sometimes we find new things and then we just do a whole bunch in a really short period of time. So if we start with the same or different and we do 1 and then we do 2, if we continue to do a whole bunch of them in the same time period, I mean, coming back to it day by day is something, but if we try to do too many of them in a short period of time, I do find that the kids get a little bit bored.
We're practicing our wait time strategy.
I also find that in a virtual space, it's so much longer because you have to give the time for the thinking, but then also time for the output. So many things going on here.
I just like to pick up on one of the things that Amanda did when she was modeling a routine. Speaking of wait time, where you give that time, you know, I don't want to hear from anyone. Like this, I want initially silence just to give that time for thinking, because otherwise, you know, when there's that flurry of responses, then that might shut some kids down because maybe their idea was taken right away, or maybe that's an idea that sounds so much higher level than what they would have come up with, and they might not feel secure about sharing it. So having those opportunities for all kids to be able to contribute something, and that kind of wait time, maybe turn and talk with a partner first before you share it to the class, are things just so that, because these things will naturally draw every kid in, we don't want to defeat that by just making it open and say, okay, everybody go all at once.
The other thing that I like to do with students here is to actually use some of our hand signs that you might use with a number talk, and to have kids when they have something to give you a thumbs up. So then you as a teacher can really quickly see where your students are at in their thinking, and it really gives students a moment where if they have additional pieces, they could give you another finger or another one or even another one. So you can get a little bit of that formative feedback as well. And then once you can see that your students are ready to go, then you can move on in that wait time of how long do I wait and how long is enough. That's a fast way to know where your students are at.
Yeah, and even in a virtual setting, they could put a thumbs up in the chat if you weren't able to see all their faces on the screen. I guess it's too bad there isn't an emoji like this and like this and like this. There's another hand signal with number talks that's also great for feeling part of the community. Even if somebody else shares an idea, if you had the same idea, then you can do this. The symbol is like, yeah, you and I were thinking the same thing, or I like what you said, or I agree with what you said. It's a nice gesture as well. All right, I think we'll get on to our next steps, and I'll be doing this part. Correct, Amanda?
You rock and roll, Mark.
All right. Correct, Amanda. It almost sounds like correctamundo. Anyway. Okay, so some next steps. So we'd like you, I mean, I know a lot of you probably have already tried some of these, but make a point between now and next time of actually trying one or more than one, but not too many, as Amanda referred to. Something that involves similarities and differences, and really think about that aspect of them. That these are not just activities to do for the sake of doing something, but they are oriented towards looking for those similarities and differences. So be very intentional about that and try one or more of those. And reflect on, especially around what did you notice about your learners? You can reflect on other things as well. Maybe either, what was challenging to you was trying to choose one that you felt would work, or, there's other things that may come up. But ultimately, whatever instructional decisions we make, we really want to see, what do we notice about our learners? What do we learn about our learners as they were doing this? And it might, if you haven't been using very many routines, it might take, doing it a few more times before you start to really notice some things. But no doubt you will start noticing some things once you have that intention of looking for that. So in our next session, which will be on April 21st, which is going to be about sharing math thinking and modeling notations. Okay, so that's where things like number talks will emerge. And that session will be led by Janice Nowakowski, perhaps with an assistant, I'm not sure yet. But part of that session, there will be a little chunk of time where we will invite you to share your reflections from trying out the similarity and difference types of routines. So hopefully there will be several of you that are willing to share something at our next session. And I think that's the last bullet. It looks like it is. All right, Amanda and I will stick around for another 8 minutes in case anybody else has anything they would like to ask, or if you want me to go back to a previous slide, if you wanted to comment on something specifically that you saw. Otherwise, we bid the rest of you good night, and we hope you stay well, and we'll look forward to seeing you next time. You're welcome, everyone.
Really good to be with you. I'm on spring break.
Oh,
What? Actually, I think I'll stop recording here.
yeah, that's probably a good idea.